But way out there in space, there's huge clouds of dust and gas. And if one of those clouds of dust and gas is massive enough, its own gravity causes it to start to collapse. So it falls in on itself, and towards the centre of that cloud, it gets denser and denser, it gets hotter and hotter. And eventually, the particles that the gas and the dust are made of are brought so close together that they start to stick together, they start to fuse. That's the energy source of a star. The star switches on and begins to shine.
Inside every newborn star, hydrogen atoms are fused together to make helium. This process is called fusion, and it creates the energy that powers every star. What happens to a star during the rest of its life depends on how massive it is at its birth.
A star like the Sun is in a delicate balance between gravity, which wants to make the star collapse in on itself, and the pressure that pushes outwards that comes from the energy that's been produced in these fusion reactions happening at its core. However, at some point in the future, the hydrogen runs out, and at that point, the core of the star will start to collapse in on itself under its own weight. It gets denser, it gets hotter, until a point where you can actually start to use the helium atoms themselves as the fuel for the fusion, pushing helium atoms together and making carbon and oxygen the next heavier elements in the periodic table.
As the star begins to fuse helium, it creates more energy, and that causes the outer layers of the star to expand. One day, our Sun will grow so large it will swallow up the inner planets of the solar system, out as far as the Earth. It will become a red giant. For the Sun, this will be the beginning of the end.
What happens is that the outer layers of the star get farther and farther from the middle. The force of gravity that they feel is getting weaker and weaker. And actually, the star loses hold of its outer atmosphere. Its outer atmosphere drifts off out into space. It expands out to become a planetary nebula. And they're some of the most beautiful objects in the universe.
Once the outer layers have drifted away, all that is left of the star is its core.
A white dwarf star is the dead remnant core of a star like the Sun at the end of its life. What's left behind is something that might weigh as much as half the mass of the Sun, but it's only about the size of the Earth. So it's an incredibly dense object, it's dead, there's no nuclear fusion going on it anymore, it's incredibly hot, but then over millions of years it will gradually cool down to become a black dwarf.
Some stars, however, are much more massive than the Sun, and they lead very different lives. They are able to fuse heavier and heavier elements inside their core. The star gets bigger and bigger. Some grow up to 1,000 times the size of our Sun, until it has fused elements all the way up to iron.
And once we've formed an iron core, there's no more energy can be got from fusion. That core collapses. The rest of the star starts to collapse in after it, but then it bounces off. There's a huge shock wave, and in just a second, bang! The outer parts of the star are blasted off into space in a huge supernova explosion. These supernova explosions are so powerful that when one of these stars explodes, it can actually outshine the whole galaxy of which it's part, a galaxy of maybe 100,000 million stars.
For these supergiant stars, all that is left is the super-dense core, known as a neutron star, an object that can have a mass greater than our Sun but be less than 20 kilometers across. But for the most massive stars of all, we think when the core collapses, the gravity is so strong, it becomes a black hole, from which not even light can escape.
So stars are actually the places in the universe where the elements are created.
After the Big Bang, our universe contained only hydrogen and helium. All the other heavier elements were therefore fused inside stars.
The amazing thing is that virtually everything you see around you was made inside a star billions of years ago before the Sun and the planets were formed. And when that star died and blasted its guts out into space, that formed the raw materials from which our Sun, the planet Earth, and indeed ourselves were made. And actually, I think that ultimately that's one of the major reasons why I think understanding stars is crucial, because it's actually telling us where we came from.